Hey, everybody, welcome back to The Doctor is In. I'm your host, Dr. Nadia Saba. Today, I want to talk about air quality, specifically about air purifiers and the claims that are made about how they can improve the quality of the air in your indoor production facility, your greenhouse, and whether or not that's true, and what are the various technologies that you might see out there at, in an exhibit hall or at a product show, or a salesman calling on you saying they have the greatest, latest, newest technology that's going to kill all the mold and bacteria in your air. So the title of today's podcast is, are air purifiers fake technology? Okay, so let's get into it. So, many indoor growers and greenhouse growers, they struggle with mold contamination, right, on the surfaces of their plants, of the surfaces of their crops. And most commonly, what I'm hearing people, distress about is powdery mildew and botrytis. And, these are really two very common mold spores that we see in all of agricultural and plant production. And, they are really transmitted in three different ways, three vectors, right? One is by touch. One is by water, contamination, water splashing, and the second can be through air currents, right? Through the movement of air. Now, mold spores, right, are commonly dispersed through the air, at least the molds, right, that affect our plants. But viruses and bacteria that might contaminate our plants are really more associated with touch and with water. In fact, there are no known viruses or bacteria that infect plants that are airborne contaminants. All of them get passed through dirty tools, through touching the plant with your fingers or your body or your clothes, or they live in the water, and that's why we have water treatment systems, right, and do everything we can do to protect the root zone and the substrate so that we don't get certain viruses and bacteria at the root level. But when it comes to what's happening in the canopy and the plant that's above ground, all of the contaminants that are airborne are mold spores. They are not viruses or bacteria. So, just to step back a little bit in terms of powdery mildew and botrytis, powdery mildew, although it needs, moisture in order to sporulate, in order for those spores to propagate, those mold spores transfer best in really dry air. And so, when we talk to growers who are targeting a really high VPD or a high relative humidity, I get really concerned that if they also have a lot of air movement from a ton of circulating fans, oscillating fans, whatever, that they could actually be creating a bigger problem by dispersing those powdery mildew spores through the dry air that they're targeting. So, that's how powdery mildew likes to get around. Now, botrytis, on the other hand, it doesn't matter if the air is wet or dry, it's going to pass through air currents as well as touch. And botrytis really likes cool temperatures, something that's less than 75 degrees. And they also really like to grow in the shade, right? Where there's not a lot of light that could, affect their growth. And so that's why a lot of times we see powdery mildew inside a flower, right? Or inside a very dense leaf spot, right? Is because that botrytis is really trying to find sort of that darkness, that wet space, where it can propagate the best. So powdery mildew, it likes to transfer through dry conditions, but it's going to need some moisture in order to grow. And botrytis, it doesn't matter either way whether the air is dry or humid, but it really wants to settle and grow in sort of a dark, wet spot that's nice and cool. Okay. So that's, mold at its best. And mold spores in generally are about 2.5 microns in size or larger. So they're actually a fairly large particle size. In fact, it's kind of on the order of like skin or pet dander, things that we can actually see floating in the air as opposed to viruses and bacteria. Okay, so let's get into air purifiers and what they are. So there are a lot of different technologies that people claim to purify the air. And what they mean by purifying the air is to remove any sort of airborne contaminants, right, that might affect your health, might produce odors, or might be otherwise harmful. And in CEA, right, in controlled environment agriculture, the claim is that, air purifiers are going to reduce the spread and incidence of mold or other, contaminants to your plant. Uh, you know, Interestingly, one of my very first projects 7 or 8 years ago was with one of the large MSOs now, and they got a call from a sales guy who said, he had this air purifier and wanted to sell this grower on the technology. And they were smart enough to call me and say, "Hey, Nadia, what do you think about this air purifier that the sales guy is, trying to sell us on? I mean, his pitch sounds really good. We want to avoid powdery mildew and botrytis, and we want to throw everything at it that we can to avoid, that mold contamination. Do you think these air purifiers are going to work?" And so, I took a look at them, and it was basically an ionization machine. And so I shared with them not just my own professional opinion, but also the results of an ASHRAE position paper that had been published recently in 2015 that kind of talked about all various types of air filtration and air purification technologies. And they really warned against many of the air purifying technologies and their efficacy against the claims that are being made, as well as, the potential harm that they can do to people and plants. For ASHRAE, it was people in the space that it's attempting to clean. So anyway, I think they walked back, and they told the sales guy, thanks, but no thanks, we're going to try something else. So finding ways to clean the air is not anything new, right? When it comes to growing plants, this is something everyone is, of course, we want to create the healthiest environments for our plants to grow, not just for the plants, but also so that, we have less product loss, less risk to our plants, and of course, have the greatest yield and quality and profits. So, what are the various types of air purification technologies? Okay, so I'm going to break down a few of them. I'm sure there's others out there. Some of them combine technologies, but we're going to talk about the big ones. So, the first one that I want to talk about are electronic ionizers. You might also hear them called ion generators. Okay, so basically what these are doing is that they are using a high voltage of electricity to electrically charge or ionize air molecules. Okay, so they're producing either negatively or positively charged ions or air molecules that are now, because they're charged up, they're going to attract particles, aka contaminants, to them. And so now the air is capturing, right? These ions in the air are capturing those contaminants, and then they get really heavy and then they fall, probably down into whatever this machine is that's doing that ionization work. So that's how those contaminants will get removed from the air. Now, one of the problems with ionizers is that, this high charge of electricity creates this corona, and this corona is filled with ozone. And so that ozone also helps to decontaminate the air by a process of ozonation or oxidation. And, the challenge with using ionizers in a grow room is that if we are producing ozone, we know that ozone is bad for our health, right? So ozone can oxidize um, plant tissues. And what that means is that it can literally burn the tissues. And if that ozone is produced right next to a plant, the plant will suck it in to its stomata, and now we're burning the inside plant tissues. So what is going to happen, right? We're going to reduce photosynthesis. We're going to reduce, I'm sure, transpiration. We are going to harm the flowering process, and we're going to reduce the plant's natural defense mechanisms. So ozone, because it's oxidizing the air and it's creating these ions, that's great if all we're doing is targeting the contaminant. But if any of that ozone leaks out of these units, which it will if it's like one of those little compact air purifiers, then if it's sitting right next to a plant, right, or near your crop, then that ozone can get sucked into the plant and cause it a lot of harm. And instead of increasing yield, right, you might actually decrease its yield because you're hurting those tissues. The other thing is, like, if we're reducing the defense mechanism of the plant, its natural defense mechanism, then, if there are still mold spores in the space, right now it's more defenseless against those mold spores than if we just let those mold spores kind of, float around and let the plant defend itself. So, using an air purifying technology that generates ozone is not usually a good idea for plants. I mean, the same is true for humans. The second technology is really similar to ionization, and we call this photocatalytic oxidation, or PCO. It's totally the same idea, but instead of using a high voltage electrical charge, now we're going to use UV as the means of activating this ionization process. And now what we're doing is we are basically using UV to light up metal rods. And these metal rods can be made up of all kinds of materials. The most common you might hear of is titanium oxide or zinc oxide. And there's a few others as well. And so now what happens is, rather than ionizing the air, now what we're doing is we're basically charging these metal rods that make them attractive to the contaminants, to the particles that are in the air. So now, those mold spores or whatever contaminant are now going to get, absorbed by the metal rod as opposed to the air molecules themselves. So, like I said, it's UV. The most, it can be ranging anywhere from 200 to 400 nanometers from the UVV, UVA, UVC spectrums of light. And one of the ways that PCO works is that it generates free radicals. Now, for those of my listeners who are health conscious, you've heard of free radicals, right? That's why we like to eat antioxidant sort of fruits and vegetables, right? Like spinach and kale and blueberries, right? There's all these great, right? The darker the vegetable, the bluer the fruit, right? The more it will remove those free radicals from our system. Well, right, if we're trying to kill these contaminants, one of the ways we can do it is by generating free radicals. Well, I don't know about you, but that scares the living bejesus out of me, because if this PCO technology is generating free radicals to kill the contaminants, what does that mean for me, right? I got to eat more blueberries, but more importantly, what does that mean for our plants? Right? Can we feed them blueberries? What kind of antioxidants can we feed our plants to fight against these free radicals that we are purposefully generating in this room to kill some mold spores. I don't know. The risk seems a little too high for me to recommend PCO under any circumstance, honestly. The other thing is that it also generates ozone. So we already talked about why ozone is bad. And on top of that, you guys, PCO generates a lot of other toxic chemicals like formaldehyde and acetic acid and formic acid. Like, I cannot even think of a worse technology that we would ever want to use around anything, honestly, let alone our plants and our greenhouses and indoor plant environments. So if anyone comes up to you and or wants to sell you PCO, photocatalytic oxidation system, run away. Okay, just run away. I'd rather you use ionization than PCO. It is just bad, bad, bad. Okay, so the third technology that I want to talk about is UV. Okay, you might hear ultraviolet germicidal irradiation, UVGI. All this means is that we are using UV lamps to kill any sort of airborne contaminants. It could also be waterborne contaminants. And so typically we're using UVC wavelength of light, which is between 200 and 300 nanometers, about 250, 260, I think is, the ideal range of the spectrum of light. And so, UV is really effective at inactivating microorganisms because it denatures their DNA, right? Just like when we get a sunburn, right? Because we have too much exposure from UV, over time we could get skin cancer because we've damaged the DNA cells in our skin so much that it can't reproduce normal, healthy skin. So the same idea is true here, is that we're using the UV to break up, denature the proteins, the DNA protein in the mold spore or other contaminant, and so, it dies. We basically create cancer immediately and it dies. And so this can be very effective as well. However, again, if we were to use UV light directly on the plant tissue, right? If we were going to expose the plant directly to UV light, we could actually do the same thing to the plants, right? Is that we could be denaturing their proteins, denaturing their cellular function, that we could damage the plant. So, I know in the old days, some growers were using like a UV wand and running it across their plants to try to kill mold spores. It probably wasn't very effective because you really need a long incidence time, a long period of time for that ray of light to become, in contact with the contaminant, with the cell tissue in order to do any harm, in order to break it up. And so chances are, that wasn't very effective for mold spores, but also they were risking damaging the tissue of their plant by directly exposing them to UV. So UV light is very effective when it has a long exposure time to the air or to whatever we are trying to, decontaminate. It also works better when the contaminant is very close to the UV lamp, because the further away that contaminant is from the UV light, right, that UV light is going to be passing through other air molecules. And so it's going to lose its energy until eventually it becomes, violet light and blue light and red light. And so it will be less and less effective the further away that contaminating particle is from the lamp itself. So first, right, we need to make sure that, those particles are close to the lamp, that there's also a direct line of sight with that lamp, right? If the UV light hits another surface or another particle first, it's not going to see that other particle. So there has to be a direct line of sight. And then we want it to be exposed to UV light for as long as possible to make sure that it has enough time to do the work of breaking down that DNA. So, to use UV light maybe in sort of like once through kind of, again, like little unit sitting in the room might not be super effective because, there's not a long exposure time. And also, the air, it's only really purifying or processing the air that's directly around it. The last thing I just want to mention about using UV light is that although it can be very effective, UV can also create ozone, especially at sort of the higher wavelengths of light, right? And so if you're going to use UV, then you also want to be really careful about putting those UV lamps in close proximity to our plants or even to our where our people are working, because the ozone that's generated can still escape, get sucked in by, the stomata, or get inhaled by people. So be careful with UV. Even though it is effective, we probably want it to be as far away from the occupied zone as possible, and maybe put it in our ductwork for our HVAC system. Okay, so that's the third method, is UVGI. A fourth method is just straight up ozonation. Uh, you already know how I feel about ozonation, right? Bad for people, bad for plants, and only effective as much as we can process the air through it. And so if you have someone just saying, "Hey, I have an ozonating machine," chances are it's either using electric ionization or it's using PCO to generate that ozone. So again, maybe you don't want to do that. Okay, the fifth technology I want to just touch on are HEPA filters. These are not necessarily air purifiers, though sometimes you do see HEPA filters integrated into those other air purifying technologies like ionizers and photocatalytic oxidizers. What I want to say about HEPA is that HEPA is really effective for very small particles, small contaminants like a virus. So that's like less than 0.1 micron. Now remember, our mold spores are 2.5 microns or larger. So to use a HEPA filter on such large particles is basically, like taking a machete to something that really needs a scalpel. Or maybe the analogy is the other way around, is that we're taking a scalpel when all we really need is just a machete to chop the thing down. Right. And so when people say to me, "Hey, I want to install HEPA filters," the question is, well, why? If plants are not infected by airborne viruses, then having a HEPA filter isn't really protecting your plants from airborne contaminants. What it could be doing, though, is protecting your people from airborne contaminants, right? We have a lot of viruses, right? The coronavirus, the cold virus, the norovirus, the flu virus, right? All of those viruses that are airborne that we inhale, yes, they can be controlled by HEPA filters. That's great. But if you're trying to do it to protect your plants, don't bother. Maybe put your HEPA filters in, in the office. Maybe put them in the locker room to protect your people, but you really don't need them to protect plants. What you need is good hygiene to avoid, right, transmitting, hop latent viroid, for example. That is not transmitted through the air. That's usually probably transmitted through tools, right? And through handling those plants, not the air. Okay, so now you ask, well, Nadia, what is effective against mold spores, right? What can I use that is safe for my plants, that's safe for my people, that doesn't do more than it needs to, or doesn't do less than it's supposed to? And my answer to that is MERV filters. All you need are really good particle filters in your air handling equipment. And all it really takes is MERV 11 filter in order to control mold spores. So mold spores are, like I said, about 2.5 microns in size. And so any MERV rating better than really 9 is going to be effective at capturing and collecting those mold spores as the air passes through it. So, at minimum, I would recommend MERV 11. More typically, we would recommend a MERV 8 to remove larger particles, like, say, dust and pollen, and maybe some of the oils, right, that are being given off by your plant. And then following that, right after that, is to then put in a MERV 13 filter that can then filter out the smaller particles like mold spores. Again, you don't need HEPA filters to filter out mold spores. You need just a really good particle filter. Okay, so are air purifiers fake technology? Well, I'm gonna give the engineer's answer, which is that it depends, okay? It depends on which technology and method you're using. Ionization, photocatalytic oxidation, I would avoid them. They are more likely to produce harmful byproducts for both you and the plant than they are to actually remove the contaminants that you're trying to control and provide better air quality for your plants. So at least avoid those two. The other thing is that it really depends on how the technology is implemented. Recent studies have shown that air purifiers might actually help to disperse contaminants further into the room than control them. So a lot of these air purifiers come with different fan settings. And so, at a low setting, at the low fan setting, it actually can't really circulate enough air to be very effective. Okay, so you're like, okay, well, the low setting doesn't work. So now I'm going to crank it up to 11, right, to the high setting. And now what happens is that blower is blowing so hard out, blowing the sort of the clean air away from it, that now any sort of contaminants that might be in the path of that discharge now get dispersed to a further place in the room. So if you only had an issue right here and you turn your air purifier up to a high velocity, now you could actually be contaminating plants that are further away from that air purifier. That doesn't seem like a good idea either. But then if you turn it at a low velocity, right, it's not actually going to churn through enough air to be effective. So there's going to be a balance, right, in terms of how you use that system. The other thing is, where they're installed. So I just described, right, like you have contaminants here, and so you put the unit here, and what the risk is of that. But the other thing is that, where you locate that equipment is going to affect how effective that technology is, right? If you put an in-room air purifier far away from the contaminant, then, you might not be decontaminating the air like you want to. But now if you put it close to the contaminant, you might actually be contaminating other parts of the room. The other thing is, how many of these things do you need, right? If you have I don't know, if you have like a 2,000 square foot room, how do you know how many of these units you need in order to process the full volume of air that's in that room? Do you need to process the full volume of air that's in that room? Or if you scout just one area, is putting an air purifier just over there enough, right? And so now do you want to move this air purifier around as, I don't know, that high velocity fan blows the contaminants from one side of the room to the other, and now you're chasing the contaminants in that room. So, just knowing where you want to put them, how many you want, right? It's all going to affect its efficacy. Not to mention if you have, if you're using UV light, or maybe you are using ionizers or PCO machines that are generating ozone and these free radicals and other sort of byproducts that we don't really want, is that now if you put them close to the plant, right? Because you scouted that this corner of the room has a mold issue, a powdery mildew issue, and so now, you're going to put that air purifier right next to it, is that now those other contaminants that are being produced by the machine could actually be harming your plant, maybe even more than the mold that we were trying to control. And if your people are walking within that proximity, we're now exposing them to ozone and these free radicals and formaldehyde, right? So it becomes really tricky in terms of how we even implement the air purifiers that we would consider safe, or at least safer than the other ones. That's one of the beauties about mechanical particle filters, is that, one, they don't produce any contaminants themselves in their process, but also they are outside of the room, right? Or usually they are, if we have an air handling unit or a packaged unit, is that they're sitting outside of the room, and all we have to do is change out the filters, right? We don't have to worry about another electrical connection to create this high voltage, air. We don't have to hook up a UV lamp to it, which also can use a lot of power, especially if we're trying to rely on enough UV, right, to have enough exposure time to that contaminated air. All of a sudden, we need a lot of power to do that too. A mechanical filter, right, is inert, right? I mean, yes, we need enough fan power in that air handler to push the air through it. But we account for that when we're engineering and designing the HVAC system, or at least we should be. So, mechanical filter, I always make the case for, because it can remove those mold spores. It removes the contaminants that we're most concerned about with the plant. It's outside of the space. It doesn't use power in order to use it. And it's just safe in general. So, when you're thinking about using air purification technology or filtration, it's really important to understand, everything that's associated with it, right? Its effectiveness, its use of power, its effect on, the room at large and your people. So, are air purifiers fake technology? In my professional opinion, I would say yes, it is fake technology. And in reality, it's really a band aid to try and fix systemic environmental control issues that you might have been dealing with for a really long time, right? And so rather than spending a lot of money on replacing your HVAC equipment or learning new techniques to manage, air quality and hygiene in your facility, or even being open to some new, climate set points and control strategies, it feels good to say that, at least I'm trying something, right? And investing in some low cost air purifiers is trying something. But is it actually working? Is it actually addressing the issues that the current grower, have been dealing with probably for many years, right? At this point, it might be time to really look into a permanent solution rather than a temporary fix. Now, I will say that air purifiers do have their time and place, and we don't not always specify air purifiers. There are some cases where we do. If you'd like to learn about when we might recommend air purifiers, give us a call. If you want to look into more permanent solutions and are interested in other strategies, maybe some consulting to help you get your air quality, get your environmental control under control, also give us a call. And if you're even just interested in learning more and would like a copy of ASHRAE's position paper on air filtration and air purification, we have a copy. I don't think it's accessible to everyone. I'm not sure that it's open source yet. You can also contact me. And, any of those questions, right? Some consulting, just some curiosity, you can contact me at The doctor is in at drgreenhouse.com. Thank you so much for listening in. And by the way, if you want to learn more about air quality strategies in general, I go through a bunch of other strategies other than just air filtration, air purification in my podcast episode number 48, which I recorded a couple of years ago. You can find that also online or where you found this podcast. Okay, everyone. Well, have a great day. I wish you all the best air quality in the world and no mold at your facility. All right, take care.